Hello Year 8s, it's the second video of the week talking through the second My Maths task. So welcome back if you've seen the other video, or welcome if you've not seen that one yet. Okay, right, so another scatter diagram. This time questions are slightly more difficult, but very doable if you follow what I'm doing. Okay, so it says, a builder quotes a fixed price for each job he does. So that's the cost that it's going to take him to just get there before he's even started working. The table and graph show how many hours he spent on his last 9 jobs, together with his charge in pounds. Okay, so from a 2-hour job being £140 all the way up to a 14-hour job being 598. And as you'd expect, the more hours he's spending on a job, the more it costs to do. There's a little bit of a wobble in the middle where 2 7-hour jobs cost slightly different amounts, and then this 8-hour job was slightly less than that one. So it's not exactly a straight line. Okay, now it says it tells us the mean time taken was 8.44 hours. So we could add all those up and divide by 9 to find the mean. Okay, but this says find the mean amount charged. So I'm going to start by adding all these up. I'm not going to do this in my head, I've worked this out already. It's £3,556. And then I'm going to say the mean amount is that amount divided by 9. Okay, and that's going to come out as £395.11. So that's what I'm going to type in there when I come onto My Maths. Or like me, you could do a screenshot and write it in by hand if you wanted. Okay, and then send me a picture of it if you want. So then plot the mean point on the graph. So mean time in hours is 8.44. The mean cost is £395.11. And that's about there. So I'm going to plot that on. And then this time when I come to draw the line of best fit, now if you're doing this on a computer screen, like I said on the last video, you'll need to click on the pen and move it over here and then click and drag for your line of best fit. If you're doing it on a tablet, you should be able to get it working. I've took a couple of tries to do it. Don't worry if not, just email me and let me know that you haven't been able to do it. Okay, but if you're doing it on a laptop or a desktop computer, should be no problem at all with it. Okay, and this time I'm going to make sure that my line of best fit goes through that mean point there. Okay, I'm not going to try and force it through the origin. I'm going to make sure that it goes through that point there. So that's my line of best fit that I draw. Okay, I've gone a bit wonky there with my ruler, but you're going to do it on the computer, so absolutely no problem getting a straight line, but make sure that it goes through there. I'm not going to try and force it through the origin because that's a false origin anyway. That's not going down to £0. Okay, and like it said, so there'll be a fixed cost. So even if he doesn't come out and do any work, he spends no hours doing the job, he's still going to charge you about £100. Okay, so second question, a little bit different. This takes us back to the work that we were doing a couple of weeks ago on finding the equation of a straight line. Okay, and let's have a look. The graph shows the number of calls that Pete made on his mobile phone each month last year and his bill for the month. I guess back in the days when people used mobile phones for calling rather than texting and chatting. So write down the equation of the line of best fit. So it's got this amount of n plus a constant. Now this constant term here is my intercept. That's 30. Okay, I can just write that on straight in there. This number here is going to be the gradient of the line. Now those of you who watched a video a couple of weeks ago will remember that we're going to say that the difference in the y divided by the difference in the x is what's going to tell me my gradient. And in this case, the difference in the y from £30 to £50 is 20. The difference in the x from 0 to 50, that's 50. So difference in y, 20 divided by 50. 20 divided by 50, well, that's 2/5 or 0.4. 0.4 in there, and that's the gradient of this line. The difference in the y is 20, the difference in the x is 50, and it's a division. Okay, so quite a tricky thing to do there to bring that back in, because I've given you this hint. Hopefully you'll be able to do it no problem when you come to see your graph. And then it says, what's the extra cost of each call Pete makes? Well, that means that as it's going up in 0.4s, so that's 40 pence. It's actually the same number here, £0.4, 40 pence. Estimate how much Pete would pay in a month where he made 35 calls. Well, I can do that in one of two ways. I can either read off the line, go up to 35 and read across, or I can be a little bit sneaky and I can say that B equals 0.4 times 35 add on 30. And if I work that out, then I'm going to get 14 plus 30. It's going to be £44, which is exactly what I'd get if I read off 35 and then read across there to 44. But this is actually using the equation of the line. So this is a tricky technique. Okay, but now you've seen my video to help you out. Hopefully you'll be able to have a go at it. Don't forget to email me if you need any help, or email me to tell me that you've done. Good luck.